Okay, we're in section 4.4, least common multiple. Least common multiple. There are two ways that we can find least common multiple. We're going to go over both of those methods. On your homework tonight, I would probably lean towards the listing multiples method, which is the first one that we're going to learn. The example, in example 1, says that there's a crop rotation system that a farmer uses. I'm going to use the plant tomato. Your book uses a different plant. I like tomato plants, so that's the one we're going to choose. So the farmer plants tomatoes in one field every 6 years and in another field every 10 years. And he continues on this rotation. Here's what it wants to know. When is the next time that he will plant in both fields on the same year? So you're continuing to list multiples until you get to one that they share in common. So in method 1, we're taking multiples of 6 and 10. What I suggest that you do is to start with the larger of the two numbers. In this case, it would be 10. And start listing multiples. Remember, a multiple is that number multiplied by itself over and over and over again. So does 6 go into 10? No. So now I'm going to go to my next multiple of 10. Does 6 go into 20? No. So now I'm going to go to my next multiple. Does 6 go into 30? Yes. So my LCM is 30 years. That's how long it's going to take for the farmer to get to the point where he's planting tomatoes in both fields at the same time. LCM, by listing multiples. Now, I got the question last hour, do I need to fill in these multiples of the first number? Technically, yes. 6, 12, 18, 24, and then 30. And I can clearly see that 30 is the smallest number that they both go into. However, we're going to get to a point very quickly where you need to be able to do this mental math. So if you don't fill in the smaller of the two multiples, that's okay. All right, as long as you have your work on the larger multiple and your LCM. So here's what this looks like. Let's look at the checkpoint. All right, I want you to list your multiples, and on the second set of numbers, it's got to be in all three numbers. All right, find the least common multiple of these numbers. All right, so I start off by listing my multiples of 16 and 24. I start with the larger of the two numbers, 24. Does 16 go into 24? No, so I go to my next multiple, 48. Does 16 go into 48? So 48 is my LCM. Then for 15, 30, and 50, I start listing my multiples of 50 till I get to 150, and all three numbers go into 150. Again, the question has come up, do I need to fill in these missing multiples? I'm not going to require you to do it. On your homework, I'm looking for you to list the multiples of the largest of the three, and then to find a number using mental math that all of them will go into. All right? The least common multiple. Any questions? Emily? No, it's not factors, it's multiples. GCF, LCM. Keep them separate. Okay, good question. Any other questions? All right, so you know we got to deal with monomials. All right, now I'm finding the least common multiple of these. Actually, before we do that, let me backtrack. I want to do prime factorization real quick. Let me switch over here to paper. I want to go ahead and find the least common multiple of 30 and 36 through prime factorization. All right, go ahead and do the prime factorization of both and list out the prime factors. Okay, so I list out my prime factorizations, 30 and 36. I've got 2 times 3 times 5, and 2 times 2 times 3 times 3. All right, so now I group my common factors, 2 and 3. Essentially, I could find my GCF. What's my GCF? 6. 2 times 3 is 6. However, I'm not finding GCF, I'm finding LCM. But it's still the same process. I still write each group down in my LCM one time. And now I bring down my leftover factors. So 2, 3, and 5, I'm now going to multiply in. So what is 2 times 3 times 2 times 3 times 5? Multiply them all together. 180. 180. So that's, guys, that's how we find LCM using prime factorization. You can use either method on your homework tonight. However, I suggest listing multiples because it is a little quicker unless the numbers are really big. All right. All right. So now let's switch over to monomials. So if I'm finding the least common multiple of monomials, I am going to use the prime factorization here. So the prime factorization of 9 is what? 3 times 3. I'm going to break it down. This is something that we've done, so we should be familiar with. 3 times 3 times x times y times y. I want you to break down 15 into its prime factors. Right, so it's going to be 3 times 5 times x times y. Now I want you to circle your common factors, 3, x, and y, and write them one time in your LCM. But now, what did we just do with LCM before? We have to bring down our leftover terms. So the 3, the 5, the y, and the x, these 4 leftover terms, I now multiply into my LCM. I want you to now find what is your LCM. What is it? 45 x squared y squared. All right, I want you to do this second one on your own. 12a to the third c and 36a to the second c to the second. I want you to find the LCM of those two monomials. All right, so now let's start listing out the prime factorization. What are the common groups that you circled? 2, 2, 3, A, C. All right, so now, but don't forget, bring down your leftover. All right. Bring it down. 36a to the third c squared. Raise your hand if you got it. Okay, so now we're going to shift gears to LCD. With numbers, we're going to start with numbers, and then we're going to bring in variables. Okay? In example 3, we're now finding LCD. What do we need LCD for? In order to be able to compare fractions and see which one is truly bigger, we need to find LCD. All right, so we're going to do this by using our listing the multiples method. All right, so out of these two denominators, which one is bigger than 9? So I'm going to use mental math. Does 6 go into 9? No. Okay, so I go to the next multiple. Does 6 go into 18? Yes. Yes. How many times? 3. Okay, so 18 is my LCD. But now, how do I figure out what my numerators are going to be? How do I know? Jonathan?
You divide 18 by 6 and 9, and you would know 6 goes into 18 3 times, so you multiply 5 by 3.
Yep. All right, very good. So, how did I get from 6 to 18? I multiplied by 3. Whatever I do to the bottom, I have to do the same thing to the top. That's what we learned the other day. So it's going to be 15 over 18. 9 times 2 is 18. So 7 times 2 is 14. All right, and then we have 15 is greater. Okay, and you can leave it in that format. That would be fine. I want you to do, just do numbers 10 and 11. Okay, go ahead and do those two. Find your LCDs, compare them, and then write the greater than or less than. So look at your denominators. Okay, stay with me. Look at your denominators. Everybody look up here. Look up here. Listen to my voice. Stop talking. Okay, so I start with 20. Does 8 go into 20? No. So now I go to my next multiple of 20. Does 8 go into 40?
Yes.
Yes, it does. So 40 is my LCD. How did I get 25?
Because you multiplied.
I multiplied 8 times what is 40? 5. So 5 times 5 is 25. Now let's do our second fraction. How did I get 26? 2 times 20 is 40, so 13 times 2 is 26. Equivalent fractions, I can see that 26 is bigger. Make a little more sense? All right, so what about number 11? What's my LCD? I heard it. 60. 60. All right, so 12 times 5 is 60, and 15 times 4 is 60, so 11 times 4 is 44. 35 is less than. All right, least common denominator to compare the fractions. All right, we're going to move on, and we'll come back to this in a minute when we're working on homework. All right, one more example, two more examples. In example 4, I need to put these fractions in order from least to greatest. Well, how do I compare them? Wrong slide. How do I compare them? I need to write them all as improper fractions and then find my LCD. All right, so it says order these numbers from least to greatest. Well, they're in all different formats. They're in all different formats. Mixed numbers and improper fractions. They all need to be an improper fraction. So what is 3 and 4/15 as an improper fraction? What's it going to be? 49 over 15. 49 over 15. And now I've got all improper fractions, but what's my problem? I don't have common denominators. Find your LCD. Okay, so 30 is my LCD. How do I figure out my numerators now?
You multiply.
How did I get from 15 to 30? What did I multiply by? 2. So I do the same thing to the top. 49 times 2 is 98. Fill in the rest of your numerators. All right, what's your second numerator? What is it? 99. And then 95. Which one is the smallest? Write it in its original format. Which one is the smallest? Which one's the smallest? 19 over 6. Which one's the next smallest? 3 and 4/15. And I'll fix that in a sec. And 33 over 10. Okay? So once, guys, I've got to create my equivalent fractions, same denominators, so I can compare them and I can look at the same size all the way across. All right? I get my LCD, and then I make my equivalent fractions, and then I can compare. All right, so I've got 2 monomials. Okay? Here's my 2 monomials. And it says to rewrite these expressions with a common denominator. Well, I've got 5b and 4ab squared. So some combination of those monomials gives me an LCD. So here's what I do. I do the prime factorization of both of these terms. Break them down. You know how to do that. We did that back in 4.1. I want you to give me the prime factorization of both of these denominators. Right there on your notes. All right, so 5b is what? 5 times b. What about 4ab squared? 2 times 2 times a times b. Is there anything I can group? Sorry, times b, one more. Is there anything I can group? My b's. So now, down here in my LCM, I'm going to write my group once, But for LCM, I've got to bring down all of my leftover terms. B times 2 times 2 times 5 times A times B. And what is your LCM of these two denominators? 20AB to the second. So now you've found, stop, that is uncalled for. Your LCD, 20AB squared for both fractions. And now you have to figure out what is missing from the first fraction down to my LCD that will turn it into my LCD. Well, look at the numbers first. How do I get from 5 to 20? Multiply by 4. Now, how did I get from no A to an A? I need to multiply by an A. How do I get from a B to a B squared? Multiply by a B. So you see, guys, I'm multiplying by whatever fills in the gap to get from my old denominator to my new denominator. Whatever I do to the bottom, I do the same thing to the top. So 2 times 4 is 8. A times 8 is A squared B. Now I want you to try to find what your second numerator is going to be. Try to figure out what that missing link is. How do you get from 4AB squared to 20AB squared and multiply the top by the same term? Here's why. How do I get from 4 to 20? To multiply by 5, and then A to A and B squared to B squared, well, it's already there. I don't have to multiply by anything. So multiply top and bottom by 5, and I get 15. And that's it, guys. I'm not adding, I'm not subtracting. I'm just rewriting these fractions with an LCD. All right, let's do another one. Okay, prime factorization of your denominators. Go. See how far you can get on your own. All right, guys, prime factorization. 2 times 2 times y, 5 times x times y. What can I group? My y's. So now in my LCD, I go 2 times y times 2 times 2 times 5 times x times y. I just bring down my leftovers. I write my group once. And what do I get from my LCD? 20xy to the second. So that's my LCD. Now I take my LCD and now I've got to figure out what my numerators are going to be. How do I get from 4y squared to 20xy squared? Don't say it out loud. Try to figure out what number am I going to write, or monomial term am I going to write in parentheses. How do I get from 4y squared to 20xy squared? Multiply top and bottom by 5x. So what does it give you in the numerator? 15x squared. All right, give you a minute to do the second fraction now. How do I get from 5xy to 20xy squared? Cole, what did you multiply by?
4y.
Do you agree? Well, why didn't I multiply by an x?
Because you already have an x.
You already have an x. There's an x here and an x here. You already have an x. You don't need another x. Multiply top and bottom by 4y, and you get 8y. Who got it right?
The whole section right.
Awesome. All right, good job, guys. That's everything you need to know for 4.4.